we've talked about semiconductors having a 10-year life cycle. If you're in the wrong position in that life cycle, you might be designing that product out again in 2, 3, 4 years.
It drives and changes consumers' behavior and brand behavior. I like to think in a very reflective way.
Supply chain resilience is a real topical issue at the moment.
It's more about how they operate and how easy they are to maintain.
Where we get the best results with our customers is where that transparency is there.
Welcome everybody to the next episode of the World Made Better podcast. And this is a very special day for me because I am here today with 3 guests, and these 3 guests make up the design and manufacturing A team in terms of durability, longevity, product design, product manufacture, end-of-life care, keeping products well designed in service for as long as possible. And we're going to have a big conversation about all of that, from design, from manufacture, from obsolescence management and aftercare. And what we want are as many takeaways as possible for our audience. So whether you're a design engineer, a manufacturing engineer, an obsolescence management engineer, someone caring for long life durable products, we should have lots of things to take away, lots of things that are interesting, lots of things that are valuable, lots of things that you can apply in your day-to-day work. So we're going to open with section 1. We're going to have 6 sections to this video. Why sustainability has become a design requirement. Why is it now? Why is it topical? Just as an opening, sort of setting the scene, we've had about 3,000 conversations over the past 3 years with engineers about sustainability, and have come to the conclusion that sustainability isn't really the goal. Sustainability is the natural outcome of best practice design, best practice manufacturing, and best practice product aftercare. So before we start the questions, I'm going to introduce everybody briefly, and then give each of you the opportunity just to introduce your company, what it does, and why we're here. So we'll start with Abid, CEO and co-founder of Ardencraft Technology.
Thanks for the intro. Excited to be here on this podcast. So yeah, I'm Abid. I run an engineering company called Ardencraft. We help businesses design products from early stages all the way to mass production, and we also help businesses on the supply chain in China, in Vietnam, and more so even in UK and Europe. So the idea is we're able to take a design from an initial idea all the way to mass production.
Okay. Neil Mead from KUKA Robotics.
Thanks, John. Good morning. So my name's Neil Mead. I'm Marketing and Strategy Director for KUKA Robotics in the UK and Ireland. KUKA, long-standing global robot manufacturer based in Germany, but manufacturing globally and supplying globally these days. In the UK and Ireland, we're a supply and service organisation. We operate out of our centre in Wednesbury, where we have a training college, and also a complete service setup, handy place in the Midlands, so we can reach most parts of the country quite easily.
And Ian Wood, Rochester Electronics.
Thank you. Ian Woods, Technical Sales Manager for EMEA for Rochester Electronics. So we're a distributor and manufacturer of end-of-life semiconductor components. And as I say, primarily focused on end-of-life. So trying to help customers when the products are no longer available in the market.
Okay, thank you very much. Right, let's start with a pretty open question to Abid. When a client approaches you with a new product idea, and I guess that's quite a frequent thing, when should they be considering sustainability in that process?
Yeah.
Do they? Don't they? When should they? How does that work these days?
So I'd hate to say that it's obvious, because when you're approaching a new product, there's so much that you've got to do, right? You've got to think about the user. You've got to see if it's the right product market fit, How does it look? How does it feel? How are customers going to interact with it? And so when we're breaking this down, it's requirements, right? And quite often, sustainability comes to the end, where people are going down the design. They're like, oh, this would be a really cool marketing, unique marketing feature to add in, or they genuinely care. But as you progress through, engineering validation, design validation, you're meant to be cementing on your initial requirements. If you don't cement it down, then you have to change tooling or you have to change test criteria. And what we find is a lot of this is considered at the end, when in reality, what's helpful is as part of the requirements, you actually do, well, how do you design this for repairability? Is there any pieces that you can actually do for end of life or alternative waste materials? And there's a fun requirement I like to add is design for accessibility. How do blind people or even deaf people interact with your product? So just from those three alone, you suddenly see your requirements change a lot. You may have to remake tooling just to adhere to it. So yeah, it's very early stages, and it's thinking that there is this design criteria that matters and you have to take into account very early on.
So a checklist would be useful. Yeah, design checklist. Yeah, that makes sense. Neil, what does sustainability mean in 2026 to a company manufacturing the type of machinery and robotics and automation that you do?
Well, there's a few dimensions to this. As Abid mentioned, I think design is crucial, and our products, our robots have developed and over the years and been designed to be more energy efficient, but also smaller footprint, just more efficient generally. So they're designed to be more energy efficient via the hardware, so the arms, but also the electronics as well, the control system. And we've managed to reduce energy consumption over the last 12 years by 60%. By careful design and making sure they're more energy efficient, because it's so important for our customers now with energy costs so high. So that's one aspect to it. The other is to make the manufacturing process the robot's being used for can be more efficient and done more efficiently using a robot. Programming the robot so that it works in the most efficient way possible as well. Shortest path, smoothest way that it can work as well. And then we get to the part where the robot's in service and you need to keep it running efficiently. Therefore, it needs regular servicing, maintenance. And then that will run for a number of years, depending on the application and how much, the kind of job it's doing, how long its longevity is. But then when it does get to the end of that sort of useful life in that particular application, it can be recycled, it can be upgraded. That's maybe the first step. But if it's now really got past that, we can take it back and completely refurbish the robot and sell it on as a used robot for a different kind of application. So a number of different ways. And when we're manufacturing the robots ourselves, of course, we have to look at our own sustainability. So use as much renewable energy as possible in that process, as much recycled materials that go into the robots as well. So as I say, multidimensional really.
And just on that point, you mentioned products in service. What's the longest service a KUKA robot do you think has ever done? Is it measured in decades?
Yeah. It would be. We have customers that will just want to keep them going as long as possible. They've made a big capital investment and they want to make sure that it runs and they get their payback, which they do over and over. So they keep it running for that long. But 20 years easily, and it does depend on the application in the environment the robot's working in. I mean, if in a cement factory, it's not going to last as long and as it would if it's in a electronics assembly, for instance, or something like that. So it does depend on the application, but easily 20 years. Usually the hardware will keep going past that, but it's the electronics and the control system that needs to be upgraded to keep it going.
I mean, it's interesting that you say 20 years. From a consumer point of view, you're always thinking 1 or 2 years.
Yes.
Right? And it's really cool to see that in your design requirements, you've got it that, hey, this robot has to last 20 years. How do we go about that? And suddenly you're making very different design decisions to be able to do that.
Yeah, absolutely. I mean, they're heavy-duty pieces of equipment. They're made to last. They're made to do tough jobs. So therefore they keep going. I mean, we make sure they're good quality and they keep going, and that's one of our sort of USPs. it would be nice if customers bought a few more of them, but they keep going as long as they possibly can.
Well, that feeds perfectly into the question I'm about to ask Ian, because a lot of engineers will think about sustainability from just sort of green materials, recycling, that sort of thing. But the question is, what about component availability and obsolescence management for the type of equipment that Neil is talking about there, where, a 20-year product life cycle, I don't know what the average life cycle of a semiconductor is these days, but it's certainly not 20 years.
It's between 10 and 20 years. I mean, 20 years is a long time for semiconductors. I mean, most semiconductors are going for 10 years.
Okay.
So we're seeing multiple cycles of components, and parts go obsolete. You won't be able to get hold of them. You'll have to place large last time buy orders with your semiconductor manufacturers to support a long period. Whereas a lot of our customers are coming to us, they're talking to us about that. They're able to secure parts which are either directly in the warehouse, or they are in wafer form and ready to be produced in the future as well. It is really closely linked to sustainability, and if your product is not available, if it goes end of life, you've got redesign, you've got efforts that will cost you sustainability. It will cost you CO2. It will cost you time, money, effort for the whole company to redevelop. Whereas if you're working with companies like Rochester, you can really help mitigate a lot of those things.
It's interesting. We've already started to enter a circular conversation here, because you started we were talking about tooling changes. Tooling changes, I can appreciate the cost and complexity of that. That feeds through into that product life cycle, feeds through into that. Yeah. So here is the conversation that companies need to take place from design to you, to make sure that the bit in the middle stretches out as long as possible. Yeah, fascinating. I put down here things I've heard you discuss in the past on social media, etc. You've spoken often about the cost of small mistakes early in the design process. So again, thinking about this sustainability and durability type thing, explain. I'm trained as a design engineer, or trained as a product designer. I would love to think that every decision I made in every product I designed was perfect and right first time. It wasn't. Okay, I got things wrong. What I really wanted was a sort of sustainability angel on my shoulder, guiding me through those sort of challenges. So, what in a design environment, where are people potentially getting things wrong that would interrupt the type of workflow that we're seeing here?
I think a common issue comes from, I'm trying to put this quite lightly, it's not the lack of experience, but the lack of visibility. Okay. Visibility of the cycle within this, right? Is if you're designing imagine a plastic product, could be a wall charger, could be a power bank, it could be a chassis, is you forget that once a customer's finished with it, or it needs repair, or it's at the end of its life cycle, someone still needs to deal with the product. Otherwise, it's going straight into the scrap heap, right? And so when you're making those designs, as an example, mechanical engineers might put a clip, whereas you could actually put a screw in there, right? And when we talk about reliability, it's very different. A product lasting 1 year, 3 year, 5 years, and inherently 10, 20 years. When you're designing for 5 years, you more or less find out the product will last 10 or 20 years because it's such a big jump. And then after that jump, I mean, it's a little bit finger in the air, but that's why it's important to also think about the whole product life cycle. Right. So when you take it from the early stages, as I was saying, you can't make the tooling and get to the end stage just before manufacturing and say, hey, now how do we make it repairable? Because suddenly you have to repeat a lot of that testing process and that stages. And even the manufacturing process, for example, we came across a situation where we were laser ultrasonic welding 2 plastic pieces. and we had a drop test requirement up to 1.5 meters 26 times onto concrete rather than 6 times 1 meter onto wood. So you can see it's a really big difference.
Yeah.
And there are situations where you have to bond the material really well to be able to do it, and also where the screw fixtures in a very certain way. And so we came across a situation where we got that far, suddenly the requirements were changed, so the testing has changed, and suddenly, well, the same tools and the same testing that you were doing before just doesn't work, and suddenly you have to repeat that process, or not do it, and suddenly design a product that's for 1 year.
Yeah.
So you suddenly see at the very beginning stage, if you're not thinking about the whole life cycle, you can very quickly get into problems and suddenly say, well, it's easier for it to not be sustainable. But in actuality, if you had thought about it at the beginning, it would be a similar process, similar time, and doesn't add any cost or waste in that regard. And that's why it goes back to, I don't want to say experience, I'm missing the word, but it's like this wider context of why it's important and how it feeds through the whole channel.
Just holding on that point, in terms of education, because every year thousands of product designers, engineers, electronics engineers enter the market. I can safely say when I was training in product design, sustainability was not a subject. Now that's a long time ago. I guess all three of you guys will be talking to young engineers. From a design perspective, are the current generation of new engineers more sustainability aware?
And the obvious answer is to say yes, but it's always a yes, but. Right. If you want to be sustainable, but you learn from someone who's always going to put clips in the design, you will then put clips in the design, right?
So it's habit.
Yes.
Okay.
There's habit, there's context, there's this experience, there's familiarity. Whereas if you're getting into a habit of thinking about the whole section and actually thinking, hey, let's not use clips, that's not going to survive, how do you repair it? I keep defaulting to screws. Screws are great. They might look a little bit messy at times, but they are great. You can unscrew and repair a product, right? And if you're taking that habit, then you're going to default to screws rather than clips. And now you can apply that to even electronics, is if you've got the habit of not looking at the whole life cycle, not realizing it will end of life, then you will default to those habits.
Yes.
So I certainly see there's a higher need and want for sustainability, but it has to come from, it's almost like a team effort, right? If your managers or mentors are not used to that way of thinking either, it takes time for the whole team to get technically educated, right? It's a gap.
Yes.
And so it has to start at all levels. There's certainly a greater need, but if it doesn't trickle down top to bottom and even in the middle, where the serious work happens, then you default to, I don't want to say bad habits, but habits that are not sustainable.
Yes.
Right.
So coming straight to you on that, Ian, what are the things that get in the way of you being able to help a manufacturer extend the life of their product? Are there habitual things? What can OEMs look to address to make that process simpler and smoother? In an ideal world, what does the ideal Rochester?
I mean, I'm talking specifically about electronics here, and there's similarities to what Mead is saying. That you need to think of it really early on in the design cycle, but you need to be thinking even into detail about the components. We've talked about semiconductors having a 10-year life cycle. If you're in the wrong position in that life cycle, you might be designing that product out again in 2, 3, 4 years, which is costing you. It's costing you that sustainability. If you select the wrong package and that goes end of life, say it's specific to a certain manufacturer, the package goes end of life, then you can't get hold of that part. You've got to then redesign your whole board to use a different package. There's There's so many little things that kind of add up. And what you've got to remember for longer life cycle products, they generally tend to take longer to develop. They take longer to design. So it's got to be really in the person's head and thought about really at an early stage.
Okay. It's interesting, you were saying there about a semiconductor life cycle being 10 years, which in my mind seems quite long. But I guess, for sort of standard product like that. But as you say, the thing people are going to forget is you don't know where in that cycle you are. You could be in year 9. And fall straight into that trap within 12 months.
We often see a customer that they're just launching a product. They've spent years developing that product, testing it and certifying it, and they come to produce the product, and then the part's gone end of life. You think of aerospace or military; they're developing their products for many years. The products are life critical, so if something goes wrong with it, they need to make sure that it's going to stay. As intended, as designed, for the whole of it.
So to just summarise what you were saying there, it is know where you are in that life cycle of that device. And that's as simple as asking you guys. You're going to know roughly what that is. Or the manufacturer
typically, but we will have an open discussion about the product. I'll look at a part, and I'm looking at the risk of that part going end of life. I'm looking at the type of technology it is, what fab process. It might be a fab process that is going to close down in the next 3, 4, 5 years. I'm looking at the packages. I'm looking at a lot of different factors and evaluating the risk of that part going end of life.
So I'm just going to dwell on that slightly. Okay, so I've got a semiconductor device. There it is in my hand. I personally, I typically just think of that as the entity. But what you're saying there is it's much more than that. It's the fab process. It's the die. It's the IP. It's the part number. It's the package. It's any of those.
It's a system in itself.
It's a system in itself. Okay.
So you've got to think. It's not just there's a silicon chip within there.
Yes.
If that goes end of if that's a problem. If the parts to make the package go end of life, that's a problem. If the tester to test the device goes end of life, that's another issue. So these are all things that affect obsolescence on semiconductors.
So I'm really learning a lot from the electronics, because you're right. What happens if the packaging goes obsolete?
Yes. So
we can't
use it. Yeah, it's true.
So you've changed my mind on that now, because I'm now going to think of semiconductors as systems, not just parts. That's fascinating.
They're highly integrated circuits with multiple components within them.
Yes.
And they can be designed sustainably or unsustainably themselves as well.
Yeah, okay. And any one of those parts of that system goes obsolete. It takes the part out with it. Yeah, okay. That's fascinating. So, Neil, what lessons can the wider engineering community learn from the way that KUKA designs, manufactures and looks after its robots?
Right from the design, making sure that the product is designed for easier maintenance and regular maintenance. So our robots now use more common parts, although we have a range of robots that range in size and payload capacity. We'll use some common parts across the range to make it easier to maintain. For modularity, which makes it easier to keep spares and maintain the robots. I think condition monitoring, a robot is usually critical to the manufacturing operation, and manufacturer can't afford for that to stop. So monitoring it carefully to make sure that it's operating at the optimum. He's good for making sure it's going to be reliable, but also for an efficiency point of view, making sure it's not using more energy than it needs to. That kind of thing. Regular maintenance, it goes without saying. Okay, we've got remote condition monitoring software as well, so we can let a manufacturer know when the robot's got an issue, go and sort it out as early as possible. But regular maintenance hopefully avoids any of those kind of issues.
Yeah. Okay. So I'll just sort of conclude this section. It's interesting because to repair or to deal with semiconductors, certainly in a product repair or upgrade or maintenance process, you've got to be able to get to them. And it was interesting that you were talking about early design, design for maintenance, design for repair and accessibility. An unusual angle I've got here is that I volunteer at a repair cafe. And so I am subject to a range of products arriving. And it's interesting how some products are clearly designed to be looked after long term and how some are not. We have a phrase called screw, not glue.
Yeah.
That's repair cafe mantra.
Yeah.
So screw, not glue. So you can get to the circuit boards and you can get them out and you can make repairs or you can swap in modular parts. And we've got endless kind of case studies on that. So again, it's a design circular thought process. And I'm back to this checklist thing. Because already we've spoken about, how many things have we spoken about? Can we remember all of this already? No, we need a checklist. So yes, fascinating. Just something I was going to check with what you said. You said if you design a product to last for 5 years, it's kind of just gonna last for. So there's kind of, it's almost like a bathtub curve type thing where if you get out of that 5-year reliability risk, then it just keeps going kind of thing.
Yeah, we found this even as far as, I mean, with the electronics, it can be slightly different. You know, if you're selecting a component that lasts 5,000 cycles, it will last 5,000 cycles, but you could easily pick 10 or 15,000 cycles. And even with switches, though it's gauged to that, there's a point where all the mechanical aspects, all the electronic aspects, all the reliability testing that goes into it is, you don't know how to gauge it to last 10 years. So you go and do it as best as possible.
Okay, so it's best practice design.
Right? Suddenly you're getting into more Kaizen principles, Six Sigma, best practice. And because it becomes a guessing game. Is with like 1 to 2 years,
becomes theoretical.
It's cost. You're trying to save on the costs, and therefore you're removing a lot of these elements. Because what we found when we were even testing wall chargers or power banks during the drop test, we took it to the top of a warehouse, dropped it from 5 meters, went on the ground, didn't even crack.
No.
Because there's a point where you're bonding the plastic so well that it's not going to be like, oh, it's 1.7 meters, so I'm going to break that, right? The bond is still going to be strong. The principles behind it is still going to be really good principles, right? So therefore, they end up lasting for a long time within this.
Right, section 3. Managing obsolescence and supply chain risk. This is an interesting subject at the moment. We're sort of in Q2 2026, and supply chain resilience is a real topical issue at the moment. There's a whole bunch of stuff that's impacting technological change, heavy demand by certain industries for certain technology types. That's obsoleting some more legacy technologies, some of the more well-known, reliable technologies, and that's being extracted by AI, data centers, renewable power, the defense industry, what's going on at the moment. So let's have a little chat about supply chains. So we'll start with Abid. How should engineers think differently about the supply chain when designing products designed to last decades, 10, 50, 15, 20 years?
So I think within this, I want to introduce a wider context of historically, we have designed sustainably. Post-World War II Japan, when the kinds of principle was getting introduced, Lean Six Sigma, all of these really good QC principles, a lot of that came from, the time, the patience, but also thinking about the requirements. And it's really interesting to know, I'm sure we all remember like a Sony Walkman and a lot of these old, very old systems, right? They last. They are in museums, they are repairable, they are modular, they had modularity built in, right? Even with the cartridges you'd use in video games. So you could see that there was a point, and if you go pre-World War II America, their cars didn't last as long. Though again, the whole invention of this originated from Ford. And when you start going through this, it's like, okay, what happened after post-World War II? We discovered disposable plastic. Well, what came with that? Oh, we've suddenly got this material that's easy to use. Suddenly we don't need to do all of this advanced testing. It's almost like a shortcut. We didn't know it was going to cause all of these problems. And suddenly you start to see 80s, 90s, 2000, the shift from phones having lots of different cables and cable type to certain phones being end-of-lifed quite early, to then the EU regulation coming in that every phone must use Type-C cables. And you're starting to see the shift of, hey, we've actually gone from modularity, repairability to not, and now we're reshifting back to there. So though it seems scary and daunting what's happening in 10, 20, 25 years, actually there's a lot of industries, we've got two right here, who already are still using those principles, right? So there is still a lot of experience out there that we can rehash because this is originating from the 50s. So what I see coming out is people are hopefully going to realize this isn't new, this isn't risky. It's old principles that are coming back and becoming, I don't want to say trendy again, but they're being trendy again, right? Within this, we've learned from the mistakes and now capitalizing what we've been working on since 1950.
So it's, to a certain extent, what goes around comes around.
Exactly.
We're back into a more sustainable mindset. I wonder, you mentioned sort of driving forces there. You mentioned earlier it's a marketing advantage, but from our perspective at the SE Alliance, we're keeping a very close eye on regulation. The European Union itself, eco-design for sustainable products, corporate sustainability reporting, carbon border adjustment mechanism, as we were speaking earlier, REACH, ROCH, battery directives, as you're saying, cabling, all those sorts of things. This seems to be like a new world. Those regulations, compliance requirements, they're relatively new. You know, I was thinking in my mind, probably the first time in my career that I encountered a real sort of sustainability-driven technological shift was the move from lead to lead-free solder. Now that's probably 20 years ago. I would have thought maybe a little longer than that, 25 years ago. So my guess is that's probably when the shift kind of began, certainly at an electronics level.
That's a good question, actually.
Yeah.
Because I obviously, I was very young
You're
during
too
that
young.
age,
You're
right?
too young to remember.
I don't know 80s and 90s within that, right?
I'm the only person here old enough to remember. But yes, interesting. And that whole legislative compliance regulatory process seems to be gaining pace. I mean, 2030 has got some big deadlines, and certainly 2050 with whole carbon neutral type of stuff. So, yeah, we'll kind of park that, but you feel that's the products you design, you must be encountering those sorts of requirements, in particular batteries.
It's happening. It's a tsunami of regulations.
Yeah.
And a lot of the regulations just want transparency. They want you judging and vetting your supply chain. They want you to actually think about the whole life cycle. They want you to think as Ian was saying, the actual packaging. What is that life cycle on an IC? And incorporate all of this in, because again, it has to happen at the top and the bottom. So more transparency allows people to be more empowered, allows you to get rid of a lot of these manufacturers that are not caring about it because they have to give details on it. And that's the biggest change I'm seeing is it's this mindset of be more transparent with your design and your supply chain and your testing, and suddenly you get better results.
And that transparency would include sharing that with organisations like Rochester Early. So that is a transparency. Because there must be design teams that don't want to share anything. They're in that NDA bubble. maybe for too long.
Tend the NDA bubble, but it goes back to, are you planning for obsolescence at the beginning? And that's why you get someone like Ian involved in the process. Otherwise, you're not.
On that point, switching to Ian, could you share some examples, some real practical case study where proactive life cycle management has saved a customer cost, downtime, and redesign effort?
Yeah.
I know you've got some.
Got a couple of things. I mean,
studies.
we're talking about transparency, and that really is key, and that's where we get the best results with our customers, is where that transparency is there. So they're sharing lists of parts, not always a bit of materials, but specifically critical parts within their design. So parts that they can't redesign easily. Maybe they're sole sourced to a certain supplier. They're going to cause them big issues, and they're sharing those lists with us, so we can work earlier in the obsolescence cycle. So we can be securing the parts. We can be discussing with the original chip manufacturers about those parts, and either securing the finished goods, so parts fully manufactured by that original chip manufacturer, or the wafer to do manufacturing, or even sometimes in some instances we're securing the IP to do the silicon design and authorization to replicate that part if the design's long gone or it's being forgotten. We're doing that. So all of those, when that happens, the customer saves a lot.
Right.
They save so much money and effort and design and everything. So that's really one key thing. I guess the second example I've got running around in my head is that we've got a customer, they're in the aerospace area, and they had ASICs on their board, and the ASIC went end of life.
Right.
An ASIC is specific to the customer, so it's a specific design to them. But a lot of the chip manufacturers, they were developing their ASIC technologies, and they've made those technologies end of life. And Rochester have come in. We've been able to replicate that ASIC for that customer, and that keeps that product running in way into.
What do you mean by replicate?
So we are translating the silicon design. So because the silicon design is specific to a specific fab process, we have to translate that at cell level onto another fab process. So that's what replication is. It's form, fit, function exactly as the customer expects the product to be. For aerospace, it's important because there's no recertification, so that would be hundreds of thousands, if not millions, in recertification, and many years of certification as well. Yeah. So that's kind of a few examples of where I see.
It's interesting you're saying ASIC going end of life, because that's the one semiconductor I wouldn't have thought would have gone end of life, because it's specifically designed. There's some tooling. So what caused? Was it a access to a fabrication process?
Exactly that. The fab went end of line. They weren't able to produce the silicon anymore. So luckily, the customer was able to had the design, and we were able to get authorization from the original chip manufacturer.
Okay.
So how does that work? You got the tooling, the die. What does it mean you've taken it over?
So yes, it's a number of things, but obviously there is IP involved, because we have to test to the same stringent specifications that the original chip manufacturer has. It's everything. The tooling isn't so much, because we are translating that design to a new fab. Okay. And we may do our own package in those instances, because we're not using the same factories as.
Because I guess then you might have the same end of life problem, right? If you use the exact same.
Yeah. Yes. You don't want to design your way into a new obsolescence issue.
Exactly.
You yourself need to look forward.
Yeah.
And just on that note, those examples you've used there, what would a typical project timeline look like? Do these things if you've got product on the shelf,
So that's quick turnaround. So if there's product on the shelf, we can ship it next day, and it can be with the customer very, very quickly. If it's design, if there's design team has to get involved, it could take a year. It could take 2 years. There is a period of time required for the design team to work through the whole process. The factory has to get all set up for that as well. There is a timeline for remanufacturing the device.
And so the quite clearly, the earlier the intervention, the more headroom you've got.
Absolutely.
To drop that. Okay. Question to Neil now. This is an interesting one. It's quite topical, hopefully, and it ties in with the whole authorization or authorized supply chain that Rochester is part of, which is robots. I remember the machine we saw at Mac, the big tonnage machine.
Titan Ultra.
The Ultra, yes, which I think was being used in renewable energy. It was battery.
Tends to be used in EV vehicle,
EVs.
vehicle manufacturing.
So you've got an enormous machine lifting heavy weights, manoeuvring those around in a kind of sustainable manufacturing arena in EVs. Now, when those machines are in operation, they're big, they're powerful. The one thing they need to be is safe. Yeah. So I'm assuming that a lot of effort is going to go into the safe operation of those, and that's going to be reflected in the design and manufacture of the electronics. So I'm assuming that KUKA is going to have a very well maintained, very transparent and authorized supply chain. And that's where there would be a kind of real danger in exiting that supply chain. So just tell me about kind of regulation around robots and how that works.
Well, you're right, safety is paramount and our primary concern. Okay, so that's number one above everything else. There is a push and a lot of interest around robots working alongside humans, so more collaborative type applications with new ISO regulations which are developing all the time. That the term collaborative robot, cobot, will kind of disappear. We're bound to refer to them as cobots, but it's more now looking at the application. So if it's a collaborative application, and there in reality very few collaborative applications where you can have a robot operating alongside a human safely. Plus, a robot is never going to be working at its most efficient if it's unguarded. Okay, so even a robot which is set up to be working alongside a human in a collaborative application, it can't work at full speed. It has to monitor its environment constantly. So you don't get the most value from the robot. Obviously, there are some operations where that's fine and it will work, but they're few and far between. Usually, in a scenario like you mentioned with EV manufacturing, large robots moving large items, heavy things, they have to be guarded. There's a lot of software as well, so safe operation software. You can zone the robot, have safe zones where it can move, and obviously there's sensors and everything else. But really, guarding the robot off, having it operating as fast and efficiently as possible is always going to give you the best operation and best payback for that.
On that point, it's interesting because we're seeing. Again, and it's all part of this circular conversation, we're now seeing the design of humanoid robots. And clearly they take a kind of cobot style to a new level, and safety and security to a new level. Can you put a kind of time frame? What's your vision on that? Because if there was ever an electronic control scenario that needed to be regulated, controlled, reliable, safe, cyber secure, it's going to be that type of environment. You're almost taking robots into an aerospace automotive style regulatory environment. Is the industry what's the industry's thought process on that?
Okay. So there's lots of conversations around that at the moment.
Right.
As you can imagine, it's potentially a completely mobile robot.
Yes.
Okay. So the HSC, I've had lots of conversations with them, and they're consulting with all the robot manufacturers
Okay.
on safety and how we can make them safe, how they can safely operate
Yeah.
in any environment, whether that be a warehousing environment or a manufacturing environment where there are people anywhere near it. We're a long way away from being able to release them out into the wild. Should we say?
Yeah.
There are some people testing them. Some manufacturers are testing them. I think it's been reported that there are some automotive manufacturers that are trialing humanoid style robots, but in a very controlled environment, in a very controlled way. And so I think we're quite a way away from being able to utilise them properly.
But along that journey, because I guess that journey will continue, there is an end game. That bill of materials, once it's designed and signed off and fixed, that's going to have to be sacrosanct in terms of the safe operation of those, I would guess. And so again, that comes into authorised supply chain for all those parts.
Yeah, how they're used, what kind of safety you use with them, what kind of sensors you can use. It really is kind of opening up a completely new area that we've not had to deal with before. Obviously, there are mobile robots, but usually they're in, again, a controlled environment. They're just wheeled platforms. But when you're talking about robots that could potentially be walking around in an environment with humans, it does give you a lot more safety concerns.
So a subject that's going to keep us busy for a while.
Absolutely.
Yeah, fascinating. Right, section 4, we're going to look at repair, reuse and remanufacture. And given the article that you wrote recently, Neil, on that subject, what happens when a robot reaches its kind of effective end of life, or end of application, should we say? What happens around refurbishment, upgrade, repurposing, that sort of thing? Is there an infrastructure for handling that? How does that work?
Yeah, absolutely. So the robot, first of all, can be upgraded. So if it's been used for a long time and we got to the point where the controllers have upgraded or changed and been updated, should I say, then we can upgrade the robot with the latest controller and software. If you get to the point where we call it maybe end of life, maybe it is the end of its useful life for that particular application, it's been doing a heavy job, it could be moved perhaps into a lighter payload type application. But even then, if it's got to be replaced with a new robot by the manufacturer, then we can take the robot back. It'll go into our factory in Germany and either be completely refurbished, so disassembled completely, go through the factory and come out the other end like a brand new robot with full warranty, but at a lower cost because there's it's reusing the existing materials. So that's a possibility. But I think that it can obviously be recycled. If it's really can't be used, then materials can be recycled and reused. But we can usually refurbish certainly the arm and then put it with a new controller with the new operating system. And a manufacturer can save some of the cost by using or having or buying a refurbished robot.
Yes,
and it's a very popular way of buying a robot.
So that sort of falls under the concept of product as a service. So one way you can sort of conceptualize, or the one way I conceptualize that is, it might look like you're providing a robot. What you're actually providing is the output of that robot. It's moving something, it's articulating something, etc. And it's working hard. And robots that work in hard environments, they do get tired. I've built and worked on machines like that. And so sort of as a service model, that robot comes out back to the factory through a remanufacturing process. New robot goes into its place to continue that capability. And then that robot could be upgraded, remanufactured and back out into proper circular economy stuff.
Absolutely.
Yeah.
Because I guess what we haven't talked about is technically that's the second life of that.
Yes.
Maybe there's a third life. I don't know how many lives that product could have, right?
Potentially, yeah. It could do a job for a short amount of time and then move into another application, certainly. But we are trying to have that full circularity.
Yes.
That's the optimum, really.
That reminds me. There's an interesting model that we're looking at in terms of EV batteries. So you were saying, the Titan robot was moving EV batteries, I think.
Yeah.
The idea is that they will have 3 lives. So an EV battery, the electrical demand in the automotive is the highest. There will be a degradation of that battery. It would then move into typically industrial machinery, such as forklift trucks, that type of thing. And then when it's degraded in that environment, it could go into fixed storage, so solar storage, that type of thing. And the estimates I've heard of is that each of those would be a decade. So that battery's got 3 lives across 30 years. And the interesting thing for Rochester is the issue isn't necessarily the battery itself, it's the battery management system. Because charging it in a car, often the battery management system is an integrated part of the battery. So that charging infrastructure would then migrate across to the forklift truck and then across to the home. So that's a 30-year life cycle. And it would be interesting to see how that sector manages the battery management systems and controls for that. Yeah. So, fascinating.
I don't think people have thought about it in that way. Right.
Well, that's 30 years. That's a generation and a half of engineers.
Yeah.
But would it not be redeveloped every time? The battery management system be redeveloped every time because it's different applications and different use cases?
I don't think they want to.
Yeah, it depends what level of battery management system you're talking about as well. Because some are cell level. You have BMSs that are integrated onto the cell, and it could be as simple as 2 MOSFETs, right, to make sure if there is a short circuit, it fails safely. And then you have usually 2 or 3 more levels, obviously in aerospace and applications where it's lasting 20 or 30 years, you might go as 7, 8 different types of levels of BMSs within it. So some of them, yes, would change, especially if you're making for a different board and there's a power management aspect to it. But diving deep into actually, I don't want to say it, can you even anticipate it to that level, or do you treat it as a template to then be able to be used in other applications? I don't know.
What I've heard is there's an argument at the moment. The automotive manufacturers, I think, would prefer to integrate the battery management system into the battery itself. So there's an integrated design for assembly type thing. But in terms of sustainability and longevity, there's also a design idea where it's completely separate. So the battery is a unit by itself and the battery management system is completely separate, so that you can walk that battery through different environments and, as you say, drop in different type management systems. But likewise, as you say, I'm seeing battery management systems of real sophistication integrated at a cellular level with a chip on every cell. So I think that's a discussion still open. Are there, just out of interest, Neil, are there, I'm thinking robots, some of your robots are battery powered, aren't they? Or the automate?
There'll be a backup battery sometimes in the controller.
Are they, do you have robots powered by battery?
Generally not. No,
generally not. Okay,
use
so
they're
wired.
Power, so they're
Cable.
using
Yes. On continuing that subject, Ian, I want to just put an idea in your head. There was a case study we did recently about a new design of passenger bridge across rail tracks. I won't go into the detail, but it was, the whole design was sustainability first. It's got a product life cycle of 125 years.
Yeah.
Okay. Kind of maintenance free, effectively. That's, 5 generations of engineers are going to take care of that product. And interestingly, integrated into that is a new design of lift system. So you can either go upstairs or up in the lift. It's going to be full of control gear. It's going to be heavily regulated. It needs to be well maintained, etc. Given all of the different services you provide, how far out into the future could you support a product like that with all of the capabilities? Say you deploy everything you've got, okay, every service you've got. How would that stretch out?
So typically we've got essentially 3 stages. We've got the first stage, which will be finished goods. So we're taking the devices directly from the manufacturers. Obviously, that stock will be there until a customer orders it. So we still have products in the warehouse that is many decades old, and still used by customers all over the globe. And they're very happy with those products having that availability of those finished goods. I guess the next level is that we will bring in wafer from the manufacturers, and we store that wafer in a nitrogen environment, so it's not taken out of storage until it's needed to be manufactured. And at that stage, that wafer is then produced into a packaged device, and that would go either to the customer directly because we built the parts to that order, or we're building the parts because we see a wider demand for those parts.
Okay.
So we do sometimes build products to stock.
Right. Okay.
The last route, and we've talked about this, we've touched on this subject, the replication of the products. We've talked about that, and that is a design from the ground up, building the silicon ourselves. We would use a third-party fab, but we have to go through the whole process. The design team in the States, they will design the silicon from the cells to the original chip manufacturer's design. And we're doing this for different devices. For instance, we still produce 486 Intel processors, 8051s, that type of thing. We're still producing them, and we have the designs ourselves. So actually, there's a part on our website which shows you the pictures of the silicon, which is quite cool. You can see a catalogue, and you can see all the different designs that we have replicated. If you're a bit of a nerd or a geek or an engineer,
silicon geek.
If you want, go and have a look. It's fascinating. And even in the design centre, we've actually got pictures of our designs on the wall. So they're very proud of their silicon designs.
You're referencing some real legacy parts there.
Yep.
Do you know the oldest device that you've got in stock that you still supply?
Well, I know we started in the 80s, and I believe we still have Motorola. Our founder came from Motorola, I think it was, which went to Freescale, which is now NXP. And we still have Motorola products on the shelf.
Right.
So there's products from the 80s on the shelf in Rochester, in Newburyport.
And people will still buy this.
And people will still buy those products that need.
And so would they be buying them? This is fascinating because I'm now trying to work out why they would be buying. So would they be buying them because they want to start they want to continue manufacturing an existing product, or they want to reintroduce and remanufacture a product, or is it maintenance and repair?
It's all of the above. So
okay.
we sell small quantities to companies that are repairing their devices. We through COVID, I think we sold a microcontroller to a company that had a previous design, and they were struggling to get for the ventilators. So they introduced a new. They reintroduced the old design to get ventilators out to companies.
So that was a reintroduction.
That was a Motorola 6804. I think it was 040 from memory.
Right.
So it's a Motorola.
Yeah.
Microprocessor.
So up here, you've got the latest technologies being developed into new product designs. But down here, there's just this continuous conveyor belt of either reintroduction of product or maintenance and repair.
Look at the NXP PowerPC range of products, which they're still active, but that some of the parts are now obsolete. And those parts span 20, 30 years. Some of the newer products are still very, very much active, but the older products we're still keeping those alive. And PowerPC is widely used in all applications. We're always surprised where it's used and who makes use of these parts, and they still need them today.
Right, fascinating. Yes, and often, how can I put it? An unseen sort of layer of manufacturing that doesn't that you know isn't as obvious,
Yep.
but still exists and is still very important. Yeah, fascinating. Abid, question for you. From a design perspective, are you seeing greater demand for repairability, upgradability, and extended product life cycles? And you've alluded to it slightly by the whole idea of, isn't it nice to be able to take a product apart if you need to repair it? So are your customers or are your customers' customers wanting this? Is it a genuine request? Are you seeing more of it?
I think it's definitely going to vary from even industry to industry, product to product, because there's obviously a drive from consumers, right? Consumers would love for products to be more sustainable. We're already getting rid of plastic straws as an example, nice and easy within that. But if the customers want it and there's still a lot of products that are priced very low because they're not taking these steps, there is a pricing discussion, and will the customer actually take that jump in the price to be able to take the more sustainable route? And then there's obviously, we've talked about the idea of the habits of engineers as well. Is that sustainability journey also reinforced and backed up by the brand or the company by itself? And we've also talked about regulations, right? Regulations will definitely drive it because then you have to do it. But I think one thing we haven't talked too much about is the impact of COVID and external geopolitical factors, right? Even as recent as the last couple of months, is it drives and changes consumers' behavior and brand behavior.
Okay.
I like to think in a very reflective way, is obviously when there's a lot of turmoil, cash is tight, that plays a part. But also when there's a lot of turmoil, and hopefully you guys can comment on this as well, I'd be curious to know from your perspective, people are thinking, well, what happens if this part goes end of life? Because now they're experiencing it. They're not planning for their critical components. What are backup suppliers? What are backup routes? And design that on the PCBA. We've lost that. 80s and 90s, yeah, people were doing that, right? My co-founder, he's 52 years old. He's used to designing 3 different MCUs onto the same PCBA, but that sounds alien to a lot of modern engineers, right, within this. So yes, there's drive. It depends from industry to industry. And I'm curious, how have you guys found it as well for your respective industries? Is it more customer with the company, more external?
Well, our customers, being manufacturers, expect us to support the product, So, and we're lucky that we're designing a manufacturing industrial piece of equipment. So it doesn't, although design is a factor and we try to make them look as good as they possibly can, it's more about how they operate and how easy they are to maintain. Rather than, compared to a consumer product. But that is obviously being able to maintain and upgradability is a key concern when a manufacturer is investing in a piece of equipment.
I think you come across a good point with the different things affecting customers. COVID massively affected the electronics industry. Companies that were used to be able to just to place an order, get products just in time, that type of thing. All of a sudden, that all went out of the window. Period after COVID, we saw a lot of our customers massively stocking up on parts. And it's only just now where we're seeing that those stock levels kind of reduced to a more manageable level. I think they've learned some of their lessons. Some companies have learned more lessons than others. And I guess as we move forward, we'll continue to learn lessons about things. COVID is one thing, but suppliers, I mean, there's geopolitical things with products out of China. Some of our suppliers had troubles getting products out of China to the customers globally. We were able to help our customers in those instances because we don't just stock end of life product, we do stock active products as well. So actually I think customers are learning every time something happens.
And I was just going to say, it's interesting. I've been writing about supply chain for about 40 years now. I should have made a note of all the interruptions to supply chains over that period. I've had earthquakes,
Yes.
volcanoes, pandemics, wars, political change, technological shifts, raw material unavailability, tariffs. There is never seemed to be an end to this.
And we almost got too comfortable because I think
Yes.
2000 to 2015, no major changes.
No.
Yes, tsunami, earthquakes. I could talk all about that and how that affected Japan, right, and batteries. But we got very comfortable with just in time, and yes, we'll get those parts immediately.
We haven't mentioned the whole situation with the markets at the moment, and AI's massively created a bit of a boom. And there's a few other markets which are also like that, and I think there's more demand on the semiconductor supply chain than ever before. And we're not looking at a period where we're going to come out of this. It's going to keep on going. AI is just a bit of a monster for growth.
You've got memory.
Yep.
Is it called Ramageddon?
Yeah.
I think is the phrase,
Yeah.
if I'm not mistaken. Memory. It's that telltale.
It's not just on the RAM though; it's on the flash as well. The flash side of things is just as bad as RAM. There's only a finite supply of the wafer that goes into those devices.
Yeah.
And there's only a certain number of suppliers.
Yes.
And the core, the top big manufacturers are all focused on AI. They're putting all of their eggs in that basket.
There's an interesting little aside to this because I've written an article recently on the role that sustainable printed circuit board laminates are now moving in, because they don't use traditional glass reinforcement, which at the moment is being pulled out of the market by the AI backplanes, multi-layer AI backplanes. So all of a sudden, glass-free sustainable printed circuit boards are slotting into where FR4 would have been, and that's a shift you wouldn't have considered 12 months ago. It's a fascinating, multi-variant, unpredictable position.
And it's important to reiterate, like, to the listeners, if you're an engineer and you're designing into this, a lot of the times you come across these external factors and think, okay, right? You might not read too much into it or think that it's going to affect your job in any way. But in actuality, as you're saying, if you're running out of a key critical component or material, well, actually that affects the design criteria. What are you going to do if suddenly your copper's unavailable, rare earths are unavailable, a certain packaging die is unavailable? What do you do? Well, you have to redesign it, or you have to find alternative routes. And we are in a world where we've had a lot more instability, and therefore you have to shift your mindset and actually realize, and I think industrial applications have done this very well, is realize, hey, this is affecting me. We have to pay attention and actually start thinking about this early in the design process. Otherwise, you'll get caught out.
It would be nice, just to sort of conclude on this section, it would be nice in my mind, and I've not worked in modern computer-aided design systems or purchasing systems. I've always thought it would be nice, all of the lessons we've learned here so far today, wouldn't it be nice if that was embedded into the CAD systems, etc.? So when you make a design decision, a little thing pops up and says, guys, are you sure you want to do that? Have you not thought about this? I don't know if that
should be your voice.
I don't know if that
your
happens.
picture coming up.
Certainly
as
not
well,
mine. No. A little, as I say, someone just on your shoulder just saying,
Maybe there are AI tools coming
maybe
that are going to do that.
Maybe it's a role for AI. And in fact,
Accelerating the use of AI, which is that.
yes.
there you go.
Yeah.
Yeah.
Well, talking about AI, section 5, this is going to be interesting. So, future challenges, AI, robotics, regulation, etc. So, we're going to do a little bit of kind of crystal ball gazing, see where we go from here. So to Ian, looking ahead, what new obsolescence challenges do you expect to see following the introduction of AI? Potentially, again, we're talking sort of humanoid robotics, that type of thing, a whole new generation of increasingly complex electronics. I don't see electronics getting any simpler anytime soon.
and
So what does that mean?
We mentioned it with the memory technologies all focused on AI. I think that lower down other applications will have to adopt the same technology as AI because that's all that will be available.
Okay.
Obviously, the more software defined we get, that's a bigger challenge for end of life. So redesigning when there's a lot of software in something becomes a massive issue. Some of our customers, that it really could floor them to change one component that then results in a software redesign.
Okay.
But I did see a case, this happened during COVID, especially in China, is he said it's interesting, you won't go backwards. We found there was a big influx of ICs that were called generic ICs. So you could add it as a power management system or for your temperatures or sensors within this. And you could actually have 3 of the same IC programmed in a different way to use different features. Now, from a sustainability point of view, it's really interesting because you're removing a lot of the waste and you're standardizing it. And we are slowly learning that, yes, there's a big influx. You won't be able to use this generic ICs for AI because they're not going to be as powerful, or they won't be an ASIC, an application-specific IC, right? They could. It won't be as good, but it's this idea of, do we always need the newest, shiniest, brightest IC for your application or not? Or is there a way of standardizing this a little bit better?
And actually, in some instances where we're replicating a product and we can continually produce that for 20, 30, 40 years, people are designing those products in.
They're still designing them.
Because actually that's already gone end of life from the original chip manufacturer. So that could be another thing that we find more and more is the older technologies, which are useful for some of the lower down applications where there's not the processing power needed. They'll be using older technologies which are still available from Rochester.
Yes. So they're not prioritizing newer components because their applications don't require it. So the capabilities of those devices are still quite adequate for the job they need to do. That must be quite nice for them because they don't have to go through the redesign process or requalification process. They know they can buy them from you indefinitely. So that's de-risking that entire process, isn't it, really?
And you do get comfortable with, again, the reliability and even traceability of the component. You know, you've used it in a lot of different products in a lot of different ways for hopefully decades at that point, right? It's a growing and learning experience, and only time will be able to tell how it performs. And it's nice being able to not always go to the shiny rock, or the latest and greatest one.
The
right?
shiny, the next shiny thing. Neil, robotics often associated with productivity. How are they also contributing to sustainability? And I'm thinking from 2 directions here. Obviously themselves, because you were talking about energy efficiency, circularity, products as service. But also thinking here whether I can get you to think about how they're contributing to the manufacture of the new future of humanity, which is more digitized, more electrified, more autonomous, etc. Because that Titan was lifting up big batteries and putting them into chassis and that sort of stuff. So how are you how's your equipment contributing to future factories?
Okay. So you mentioned productivity, increased output, improved process efficiency. That's a given.
That's a
when you
given.
automate a process. With the robotics now, and we've mentioned AI quite a lot, they're becoming more adaptable.
Right.
Okay, so they can be turned to various different applications, not just fixed on one.
Yep.
And that's important. But with the introduction of AI and AI programming capability, robots have always done whatever they've been told to do. We program them, they do that job. But we're moving to more deterministic systems now with the introduction of AI, so that they can adapt depending on what the process, how the process adapts. The production line goes faster, or it has to speed up, or whatever it might be. Having some intelligence is going to really make a difference. Up until now, they just do what they're told, but we are moving what we call automation 2.0.
Oh, okay. That's a new phrase to me.
Yeah,
Automation 2.0. Okay.
Well, as you become, they become intelligent, more deterministic. That's what we're moving towards.
My background is automation, food, pharmaceutical, that type of thing. Now, when you put a machine in to perform a task, it has to have a default program. Someone has to say, I want to stick this label on, I want to put that screw in, etc. to do that. Are you suggesting that if I specialise in labelling machinery, if I designed a labelling robot today and I pre-programmed it to put a label onto a bottle or whatever it was, that robot would be able to understand what it was doing and say to itself, I think I can improve on this default program?
Potentially, yes. That's
Really?
what we're moving towards.
Okay. So factories become like neural networks themselves, and they just improve themselves every day.
Exactly that.
Okay. That's interesting.
And that's the benefit of artificial intelligence
Yes.
at the end of the day, isn't it? If it can be more adaptable and improve the process even further.
So you'd have AI at the edge with the machines monitoring their own sensor networks, improving themselves, sharing that. So one robot shares that with another robot.
Yeah.
And that means more semiconductor capability on the machine, which leads to bigger obsolescence challenges, which brings you guys in. Are you at the point where you're stocking or building any AI chips, or is it too early for that?
It's kind of too early for that.
Okay.
For us.
But that's going to come, obviously.
Of course, they're a semiconductor technology, so
So you'll have AI GPUs on your line card before long, I would imagine.
Yeah.
Interesting.
I don't know if can I say the type of chip or the manufacturer of the chips that we have in our controllers now are
Yeah.
NVIDIA chips.
Right.
To make them future-proof
Yes.
and AI
Yes.
capable.
Yes.
So that's all been thought through, and that's the reason they've been designed in with that.
Wow. So we can see a future. So you're designing products that are going to be made in factories where the robots are aware of what they're doing and are adapting themselves to improve on that process over time with the use of GPU type AI at the edge processors, which you guys are going to need to stock to keep those robots in operation for 20 years.
Yeah.
So we're back to the same circular conversation. Absolutely fascinating. What does a truly sustainable product look like in 2035? So in 10 years' time, imagine all best practice design, all best practice manufacturing is in place. What does a product, does the outcome of that look like? So it's quick fire around the table. Abid, what's it look like?
For me, it would go into the product is going to last a long time.
Okay.
Right? Is you're moving away from finite resources. I mean, there's technology coming out, salt-based batteries rather than lithium, and same with reusing like metals. You're actually taking not just recycling and assuming a plant is going to recycle it, but you're actually taking back the product.
Yeah.
And you're able to, with robots, you're giving it a second and third and fourth life. You've actually integrated that in within it. So yeah, there's a material aspect, there's a modularity aspect, there's a second and third life aspect to it as well. But effectively, from a design point of view, you're thinking about the whole life cycle within this, all the way back to you receiving it again and what you're going to do going forward.
So circularity almost at a component level.
Yeah.
Lynn?
optimize energy efficiency. So it's got to operate as efficient as possible, and that's something we're working on constantly. Anyway, obviously reliable, especially with a robot because it's in critical operation, as I've mentioned before. Upgradable as well. Upgradability is key to keep that asset operating. And recyclable, reusable.
Yep. Yeah.
Obviously, product life cycle, it's got to be designed with the end of life totally in mind. I believe the more we talk about it, the more it becomes a thing. And that will lead to a modular electronic design. I think the repairability needs to become more.
Yep.
Things need to become more modular, and so you can upgrade and reuse.
And what I see as well is, whenever I talk to people in industrial applications like yourselves, is it seems obvious. You're like, yeah, we've been doing this for a long time. But actually, for a lot of engineers, it's not obvious. It feels new. It feels like we haven't done this before. So I'd like to see more of a bridge. And this is why I love that this panel's being assembled, is you have the answers to what a lot of the engineers are worried about in a lot of different industries. But it's not new for you, right? You've been doing it for a long time. So it seems obvious. So I'd like to think there's a lot more confidence and relief people can feel that actually we're not reinventing the wheel per se. That knowledge and experience is out there, and it's been going on for decades, right? It's
and transferable. Across
yes, and it's transferable. Yeah.
Question 2. It's a bit of a trick question. This there's no right answer to this. So, should engineers prioritize recyclability or longevity?
Yeah. For me, immediately, I think longevity, right? Rather than having 10 products that you're buying again over 20 years, you have one product that lasts for 20 years, because it's this idea that materials are a finite resource. It could even be a shared resource, but you know, if you're using that material for one product and it lasts a long time, then it's great. You can't ignore the recyclability, right? Maybe recyclability is not the right word, because it's what's the second life? What's the third life? You know, it's this idea that it's a shared resource, and I don't want to get into recycling practices and how it is right now, right? Technically you don't need a recycling center if you're taking the product back and actually reusing it, and that's important to note. That's also recycling, you know, or maybe we should reframe it as giving it a second and third life, right, within this.
Neil?
It's a tricky one, isn't it?
It's
both real, isn't it?
It is both.
I think longevity first, because as you already mentioned, you know, keeping it going as long as possible is key, but then making it recyclable at the end of life is very important as well. So I can kind of both.
Yeah.
It's longevity for me. Sorry. But,
yes.
Yeah.
That's cool. It's interesting, that one. I think the car I drive at the moment is an example of a product that we're trying to keep alive as long as possible, just to see what happens. And we're at 170,000 miles at the moment. We'll re-report at 250,000 miles. But at the same time, recyclability. And what's interesting, just as an aside from me there, I reprogrammed my brain a little while ago to see products differently in terms of sustainability. When I see imported product, for example, a car rolling off a car transporter into the UK as an imported product, I don't see a car anymore. What I see is a molecular structure comprising ferrous metals, non-ferrous metals, polymers, components, etc. At that particular point, they just happen to be taking the shape of a car. But in 10 years' time, they can take the shape of anything else, provided there's a system that can make that happen. So they might still be the wing of a car that finds itself on a new car that's been repaired from accident damage, or it could be melted down in one of our new electric arc furnaces and become a new wing on a new car, or it could become an enclosure on an electric product for a motor controller for a PCB that you guys look after. So I don't see cars coming off ships anymore. I see materials, which is me reprogrammed. So quite a big question here. What is the single biggest sustainability mistake being made by the engineering sector today?
For me, there's a few, but for me, the idea of recycling, I think that's shifted a lot, right? And I won't go into the details, right? Of maybe recycling was a greenwashing mechanism. There's a lot of merits to it, but it's similar to what you just mentioned, right? As a product, it's this finite resource. It can be used in a lot of different ways, and thinking about that early on, because you can do a take back scheme, you can turn it into something else. Is how many engineers have actually repaired a product within this? I don't think many, right? And even repaired their own product, because if you take that step, you then realize how annoying your own decisions have made your life, right, within this. So I think you hit the nail on the head there. It's this idea of reprogramming our mind that there's nothing new in what we're doing. Other industries have done this for decades. There are a lot of applications of this idea of life cycle within it. And my second point, if I'm allowed the second point, is, external factors like material shortages and COVID and everything that's happening geopolitically will affect your supply chain, will affect your design. So you should be open to this new emerging way of design. Not sure what it's called just yet, but there's definitely this shift that's happening, going back to our mindset in the 80s and 90s, right?
Design 2.0. Goes nicely with automation 2.0. Yeah, Neil, biggest mistake that we could avoid?
I guess concerns that when talking about sustainability, it could lead to increased costs. If you're worried about making a product more sustainable, or everything that goes, all these different dimensions of sustainability we're talking about, that could be a perception.
Yeah, okay.
And that's always, a major concern
Yes,
for
so
manufacturers and engineers these days.
yeah, so because sustainability has often been discussed as a process that will add costs to your production process, where pretty much every case study we write about is either cost neutral or cost saving,
Exactly.
if it's done well. So yeah, interesting. Ian.
I've got written down single-use electronics. I just think that we're in a consumer world where a lot of the devices we buy are electronic, but they are then thrown away, and they're not really. They are recycled, but they're not.
Yes.
So I think that's the biggest mistake, is that we think of things
Just single-use products.
just for a single task, and then it's
Yeah, totally agree.
It's interesting what you say there is essentially what those manufacturers are doing is they're outsourcing the consequences of single-use plastic to someone else, typically the council, and thus the taxpayer, etc. They're not necessarily contributing.
It's consumerism at its worst, isn't it? It's the way we're kind of brought up to want something new all the time.
I was looking at some figures recently. There's a new automotive recycling facility setting up in Europe to disassemble vehicles and reuse those components. I did some numbers, and I think they're looking to do 20,000 vehicles a year. Okay, that's not big numbers, in the automotive industry, but it's big enough. And I looked at how many printed circuit board assemblies there are in a vehicle these days. If you go down to the smallest sensor boards and that sort of thing, on an average car, it's about 100. Okay, small car 50, big EV 150. I don't know. Now, if I've got my maths right, 20,000 times 100, I think that's 2 million. Is that 2 million?
Yes.
Yes. So that single plant is going to have a shelf somewhere, right, or more than one shelf, with 2 million printed circuit assemblies just from those 20,000 cars. Think of all of the value that resides in that. And once you start to do those numbers in your mind, you realise that there's a new industry out there if you think about it well.
Yeah. And it's not just automotive. You're starting to see it with laptops, refurbished laptops, and now I've seen some factories set up. They're offering 3 to 5 year warranty on it. Right? It's standardizing some of the parts, using the chassis, and being able to actually guarantee and move away from this idea that refurbished can't be as good as brand new.
Yeah.
Because they can, and people are giving out warranties to support that. But it comes with the ownership, right? If you want to be able to do it, then there are ways. There's a lot of knowledge out there within it.
It was interesting. I saw it kind of aligned with what you were talking about, Neil, about refurbishing and reselling as a second life product. Some motor control manufacturers who are doing just that, taking motor controllers back, refurbishing and reselling them. And the interesting thing, offering a better warranty on the refurbished one than the new one, to offset exactly what you were saying, which is this kind of fear that a refurbished product is not as good as new. So, okay, well, we're going to take that fear away by giving you twice the warranty, or whatever's necessary to do so. So, yeah.
Because sometimes it is just a small part of the component that, if you imagine the component as your phone and your battery is the first to fail, you replace the battery. Now imagine saving the motor. A motor is a product in itself. Is what's the first failure point? Can you improve on that? So that it keeps improving. And with Second Life, you have a lot of history, right, of what's failed within it. So suddenly you've now got a lot of history for a product that you know what the common failure points are. And if you were to able to improve on that, suddenly you can actually get just as good as a brand new one, if not better.
I've got this real hope. I'm not sure if it will come to fruition, but the right to repair legislation that is moving forwards is the one thing I really want from right to repair, is to be able to talk to a manufacturer, even if a product itself has gone obsolete. I don't mind, but I'd love to be able to gather together some of the failure and repair data. Just to know what the single point, most common point of failure was, so that can be engineered out of V2 or V3, or shared with the wider world to say, don't do it this way. If you could change one thing in engineering education, what would it be? So let's go backwards.
I feel that engineers come out with a great knowledge of the basics for electronics. But they come out with very little of the commercial knowledge to actually be a useful engineer. I feel that, and yes, I know that education doesn't stop at university; it continues in your career, throughout your career. But I do feel that, as I remember when I was a young engineer coming out of university, and I had no real idea of the component supply and where you'd need to go and buy from, what you'd need to think about. You just think, oh, it's a component. I'll put that component on the board every time. So I think that's the biggest thing from my perspective, is that I think that university, and I don't know if this has changed in recent years, but I feel that most universities really neglect the commercial aspects of the industry around it. I think that they focus on the core aspects, the academic, and don't have that wider commercial knowledge. So
Sure.
Neil.
Yeah, similar answer to Ian, really. I think they do concentrate a lot on the theory, but more exposure to real world applications and the issues, problems that come up would be obviously really useful for future career prospects.
So exposure to commerce. Okay.
Yeah, I certainly agree. I would add to it that in engineering, it's a lifelong learning opportunity and journey. Even if you're starting in, and I remember this, this happens over generations. Every generation thinks differently. And when millennials started, we started caring and pushing a lot more about sustainability, but we'd get a lot of flat back. Whereas now I'm starting to see a lot of millennials are now in positions of power. So when the next generations come in and be like, hey, we care about sustainability, we're actually like, yeah, actually we can break free from this idea that it might not be commercially viable, it's too expensive, or hasn't been done before. And so actually being able to be open to the idea that A, it takes time, B, it is a lifelong journey and education, and being open that you can default back to your habits or take that step And it ends up being a little bit more time, a little bit more familiarization. Again, the idea that it's all about your own education, regardless of what age you're at, to then be more comfortable and familiar with it.
Well, I'm going to answer this question myself if I'm allowed. I think I'm allowed to answer my questions. Which is, and I would say this, wouldn't I? I think university courses should be mandated to ask their students to watch videos like this. And I think that they should subscribe to trade and technical magazines so that those engineers have got something to read, because if they can't get into a factory, then videos, discussions like this, podcasts like this, and magazines like we know can be produced are the closest they're going to get. Because it's real conversations with real engineers about real challenges and real solutions. Now, maybe lots of that already goes on, maybe it doesn't, I don't know. But that's going to be my suggestion. Right, now it's the closing question. What is one practical action every engineer listening today could take next week to make their products more sustainable?
I would say, if you're designing a product, try to repair it yourself.
Yes.
Right?
I like that.
And actually get on the ins and outs, because it'll also help us. How do you assemble it? Is it easy to assemble? Suddenly, if you've got robots also helping on the assembly, you're more familiar with the process and you're able to optimize it, right? And then you've also got the sustainability piece. You know, it's not one or the other. It's going to help you in a lot of different ways. Like, have you actually sat down and tried to repair your product after it's fully assembled? Because it's going to teach you so much about your own design and the design decisions.
Excellent. Neil?
Yeah, for me, it would be more about the process rather than the product. Okay, so obviously we're supplying manufacturers. So if an engineer's in a manufacturing environment, look at your process to make that more efficient, more sustainable. Where could you automate? Don't try and automate the really complicated process that first immediately you think, yeah, I could, maybe remove some manual handling from there. Look at the simpler tasks that would be easier to automate in the first place.
Right.
And of lower cost, and obviously usually have quite a quick payback in return.
It must be so tempting to look at the complicated thing to automate first.
Absolutely, and a lot of manufacturers do, and that's when we get the call to go in.
Yes.
I've got this complicated process, I want to automate it.
Yeah.
Can you help me? And then you see a much simpler process further down the line where you could make a start and really, improve the efficiency and the throughput.
Yep.
And they don't really look at that; they look past that. So that it's a bit of an education piece when you first go in.
Yep, that's interesting. Yeah.
So I'm going to go. You've got to think about the intended life cycle of your product. If you don't know that, think about it.
Okay.
As straightforward as
simple as that.
As straightforward as that, but then align those components within the system to that intended life cycle. Okay. But there's companies out there like Rochester that are willing to help and consult, and we've always got our lines open for questions and things like that. So come and talk to us if you want to learn about life cycle and end of life. And
I can't see any reason why that shouldn't be the first question.
Yeah.
So in a product design brief, like you say, set the design brief. It's a simple enough question, isn't it?
Yeah.
Just make it the first question. You can have that discussion within 15 minutes probably. Yeah. And then that would set the scene for everything else, potentially. Interesting. What would I do? What would my recommendation be? It would be to volunteer at a repair cafe, because that takes repairing your own product a stage further, because it forces you to repair other people's products.
Yeah.
And that opens up a whole can of worms.
And great learning, right? You see other design principles, you see how other people have effectively done your role and other people's role, but in a completely different way.
Maybe that could roll back to the education piece, where every university engineering department, they just empty a box of products and they fix that part. Yeah, and see what happens. That's the end of this episode of World Made Better podcast. I really think that this has been fascinating. It's been such a beautiful circular conversation. Design, manufacture, end of life, care. I can't believe our audience is not going to be able to take away a whole bunch of interesting and useful takeaways from this. So I would like to thank you all for coming along today. Thank Rochester Electronics for making this facility available for where we've done this today, and the crew behind the camera, or behind the cameras, for all their hard work as well. So thank you very much, and hope to see you all again soon.
Thank you.
Thank
Really
you.
enjoyed it.
Thank you.
Appreciate it.